Hi, everybody. My name is William W. Davis, and welcome to my presentation, A Beginner's Guide to Probabilistic Scheduling. I'm very pleased to be part of Risk Awareness Week 2021, and I hope you'll get a lot of benefit out of this presentation. Let me share with you the agenda of how we'll spend time together. I'll share a little bit more about who I am and what is Statistical Pert. That'll include where you can find this model, what editions are available, and how it can help you. I'll do a little storytelling. I'll share with you a big scheduling problem that I faced last year and how I approached that problem using a probabilistic schedule. We'll go into a model and do a demo of how to create a probabilistic schedule similar to the one that I used to solve a big scheduling problem. And I'll wrap up by pointing you to some resources, including the model Soothsayer. I won't look at Soothsayer in this presentation, but you might be interested in Soothsayer because it will help you calculate a right-sized project schedule contingency. Let's begin. Again, my name is William W. Davis, and I have been in IT my entire career, even before it was called IT. I served as a systems analyst for half my career, and then the last half of my career, I've been an IT project manager, Scrum Master, Agilist. I do Agile coaching, I do teaching, and I work on courseware for Pluralsight, which is an IT curator of courses. I do conference speaking, including this one, and I created Statistical Pert back in 2014 and released it in 2015. So what is Statistical Pert? Good question. Well, about 7 years ago, I graduated from the George Washington University with my Master of Science in project management. I learned a lot of really good techniques and tools, and among them was this one called the Unified Scheduling Method. It was something invented by two of my professors at GW. Unified Scheduling Method is an approach for creating a scheduling buffer without having to use Monte Carlo simulation. It's a very good method to use, but it does require you to know what's the probability of a task on a schedule being exceeded, or what's the probability of success for all those critical path tasks that are on your schedule? Well, a lot of what I do is taking subject matter expertise and putting it into a project schedule. And I didn't have a good way of modeling the subject matter expertise, so I invented a way, and that way is called Statistical Pert. It takes subjective judgments about some sort of an uncertainty, and it models that using one of the probability distribution functions that are inside Microsoft Excel. Statistical Pert is an Excel-based estimation tool and technique. At the end of the day, all it is a pre-built Excel spreadsheet. I created it in 2014, launched it in 2015, and then began doing some presentations on it, including the PMI Global Congress in 2016. What's important for you to know is it is a freely licensed spreadsheet under the new General Public License. That's a copyleft license, meaning that you can download it for free, modify it, redistribute it, as long as you adhere to the license agreement. So it's free software, and I hope that after this presentation, you'll be motivated to download this spreadsheet and try out some of the things that you'll see me do in this presentation. Statistical Pert has been used by people around the world thanks to the Project Management Institute. They offer it for download at their sister site, projectmanagement.com. And these are some of the comments from people literally around the world that have gone to PMI's sister site, found the spreadsheet, downloaded it, and then made some public comments about it. I hope that you will find that it's an excellent tool as well. Here's where you will find the latest editions of all my spreadsheet models. It is at statisticalpert.com, and this is what the homepage looks like. So if you point your browser to statisticalpert.com, you'll see this web page. Click the big orange free download button in the center of the home page, and this is the download page at my site. Currently, there are 3 editions of Statistical Pert available for download, and I have a 4th one that is in the works. The one that we will look at in this presentation is the middle one, the SPERT Beta Edition, which uses the beta probability distribution to model project uncertainties. Now, how can Statistical Pert help you? Well, imagine that you and I are on a project team together, and I'm the project manager, and I come to you and I say, friend, I've got this task, it's assigned to you. I'm getting duration estimates for this task. How long do you think this task will take you to finish? And you might respond to me, most likely I can get it done in 40 hours. Okay. But add some buffer in case I run into some problems. This is where I need to take your subjective judgment about an uncertainty and map it to a probability distribution. If I can do that, then I can pull any point along the bell-shaped curve and use that value inside my project schedule. If I want to be 80% confident that you'll get this task completed, I won't put 40 hours in. That's only a 50-50 number. Instead, if I model your uncertainty using the normal distribution, I will put 47 hours in. That gives me 80% confidence that you will get this task done in 47 hours or less. There's only a 20% chance it could take you longer than 47 hours. Now, in project management, a lot of our task uncertainties are better modeled using the beta distribution, which has a long right side tail. I could ask you the same question, hey, how long will this task take? And you might respond to me similarly, saying, it'll take me about 40 hours, but add some buffer in case I run into some problems. Now, if I model this task using the beta distribution, I won't put 40 hours or 47 hours into the schedule. This time, I'll put in 60 hours. Because if this model, this bell-shaped curve using the beta distribution, is a better representation of the risk that you sense about this task, I want to make sure that I'm 80% confident you're going to get this task done. I'll use 60 hours. There's only a 20% chance it could take you longer than 60 hours. There is a 3rd edition of Statistical Pert that I will release in 2022, and it will use the log normal distribution. It's currently available on my website as a development build. The production build will be available next year. But if I use the log normal distribution, and I ask you how long will this task take, you might say 40 hours, but add some buffer in case I run into problems. If the log normal distribution is a better representation of the task uncertainty that you sense, then in this case, I would put 54 hours into the project schedule. 54 hours means that you are 80% likely to get the task done in 54 hours or less. There's only a 20% chance that it could take you longer than 54 hours. I've talked to you about 3 different editions of Statistical Pert. The normal edition that uses the normal distribution curve, the beta edition that uses the beta distribution curve, and the log normal edition, which uses the log normal distribution. There's a 4th edition that uses statistical bootstrapping, but we're not dealing with that in this presentation. Each of these models allow you to take some sort of uncertainty that you are dealing with and represent that uncertainty using probability distributions that are functions built into Microsoft Excel, but you don't have to interact with those statistical functions directly. The spreadsheets, the pre-built spreadsheets, make it very easy for you to use these distribution curves without having to deal with standard deviations and variances and means and modes directly. Why did I create Statistical Pert? I created Statistical Pert because I wanted an easy way to help people estimate uncertainties. I created Statistical Pert so it's easy, and I hope, as you will see, that it is an easy model to interact with. Now let me tell you about my big scheduling problem, which is the basis for our demo. Last year, my employer launched a big project to upgrade our ERP system, Enterprise Resource Planning. The ERP system we use is Oracle eBusiness Suite. We were going from release 12.1 to release 12.2, which doesn't sound like it ought to be a big upgrade, but in fact it really is. Going from 12.1 to 12.2 is a complete change to the technology stack, and it involves massive change to the application and those other integration points with the Oracle eBusiness Suite. So it is a big effort. Now, the planning that I did was not at the task level. I did planning at the activity level, which is a higher level of the project. And I wanted to create a project schedule at the activity level so I could answer my project sponsor's big question. The activities that I'm going to share with you now are representative of the project that I did manage. I didn't use the exact details of the project that I managed because of intellectual property that belongs to my employer. But here's some representative activities. First, there would be a procurement activity where we would find a technology partner to help us with the upgrade. We would do some discovery and planning with that technology partner to help us understand what's before us. And then there would be this cycle of activities. We would do a database upgrade, an application upgrade. We would do application configurations, remediate code that interacted with the eBusiness Suite, and of course, a lot of testing. And we would do this multiple times because we had multiple instances, a test instance, a dev instance, a QA instance. Once we did that 3 times in 3 different instances, then we would be ready to do a multi-day deployment into our production environment. So these were the high-level activities that would be part of my project schedule. Now, the project sponsor's big question is, when will it be done? And at what cost? And my response to that is, I'll tell you based upon the information that I have modeled in my project schedule. Now, at this point, I want to compare and contrast the way we would normally schedule projects with a new way, the probabilistic way. Historically, in my many years of project management work, we would use a very deterministic way of building project schedules. What you see here is Microsoft Project. Now, this is not obviously the actual schedule that I use, but represents all of the major activities and the durations of those activities. So in this scenario, we're going to say that this project would start on March 2nd, 2020, and we scheduled it to finish December 8th, 2021, about a year and a half later. It would take 443 work days. Included in this schedule are all the holidays that people have off from work. This is a deterministic schedule. There's only one possible duration outcome that we expect for each of these activities. What I actually did, though, is I took this deterministic approach and I used a probabilistic approach instead. Using the beta edition of Statistical Pert, which we'll look at in just a moment, I took those same activities, put it inside the spreadsheet, and then I mapped the same duration estimates to mirror what I had done in Microsoft Project. So the same start date, March 2nd, 2020, the same finish date, December 8th, 2021, and the same number of workdays, 443. Okay. So at this point, the deterministic schedule looks no different than the probabilistic schedule. But there is something different that I see in the probabilistic schedule. In the probabilistic schedule, I see that each duration estimate is very conservatively planned, very conservatively estimated at the 95 percentile. Each of these activities are planned in such a way that there's very little risk that this activity will take longer than the duration estimate on the schedule. Very, very conservative. And because of this very conservative stance, projects take longer than what they should. They cost more than what they should. And we do that to protect ourselves from having to tell our project sponsor our schedule is running late. We don't want to tell our sponsor that our schedule is late, so we plan very, very conservatively when we use a deterministic schedule. However, if we use a probabilistic schedule, we can be more aggressive with our duration estimates as long as we have a sufficient buffer to safeguard our project when the activity takes longer than we expected. Now, the interesting thing about the deterministic schedule is the probabilistic schedule tells us that even though each activity is planned to be 95% confident that it will finish on time or early, this project has a 1 in 3 chance of schedule success, only 34% chance that it will finish on time, and about a 2 in 3 chance that it will finish late. Well, how could that be? Each activity is planned at the 95 percentile. We have to talk about Parkinson's law. Parkinson's law tells us that work expands to fill the time allotted for it. You've probably seen this. If you tell somebody you've got 40 hours to get this task accomplished, it's going to take them 40 hours or maybe a little bit more than 40 hours. It's not uncommon for somebody to expand their work to fill the time allotted for it. This is why a lot of tasks are finished on time, but they don't finish earlier than we thought. They usually finish on time or late, but rarely do they finish earlier than we thought. And Parkinson's law explains why that is so. Work expands to fill the time allotted for it. Therefore, whether you put your duration days in a deterministic schedule or a probabilistic schedule, whatever duration you're putting in your schedule for activities or tasks that you're scheduling, those tasks or activities will likely finish on time or late. They probably aren't going to finish early. Now, let's talk about what the goal is. The goal for my project sponsor is to create a probabilistic schedule that isn't likely to fail and can finish sooner than December 8th, 2021. Our strategy is to shrink the duration time for each activity on the critical path, but include a schedule buffer for those times where the task or the activity takes longer than expected. At this point, let's transition into the demo of this presentation. I'm going to show you where you'll find Statistical Pert Beta Edition. We'll download a template, open it together, and fill out the SPERT Scheduler worksheet with those critical path activities for the ERP upgrade project. Let's do it. We will begin the demo at the homepage of the Statistical Pert website. I'll click the free download button, and that takes me to the free downloads page. And I'll click the SPERT Beta Edition, which is the template that we'll use in this presentation. There are a couple of download options. You can either download an example workbook that has some sample data in it, or you can download an Excel template that has no example data in it. Both the example workbook and the template are macro-free, so that should make you feel at ease that you're downloading something from the internet, but there is no malicious macros that are running on your computer. All of the spreadsheet models that I create are macro-free. I will click the macro-free template, and that's what we'll use for this demo. When you first open up a Statistical Pert spreadsheet, you will get a warning that you have to enable editing. That's okay. Enable editing, or else you won't be able to interact with the spreadsheet. The spreadsheet file opens up with the Welcome tab. You'll see there is a link there for a quick start guide. If you'd like to have a PDF that explains how to use this template, feel free to download the quick start guide. On the README tab, the most important thing for you to know is this spreadsheet can have slow performance unless you go to the Excel Formulas menu option, and under Calculation Options, choose Automatic except for Data Tables. This spreadsheet includes one worksheet that has a Monte Carlo simulation model in it, And that Monte Carlo simulation model has 10,000 trials of data. And if you don't change this to automatic except for data tables, anytime you're interacting with any of the cells in this spreadsheet, that Monte Carlo simulation model will re-execute and repopulate those 10,000 trials of data. That tends to make the spreadsheet a little sluggish. If you change it to automatic except for data tables, this spreadsheet should have speedy performance. You can also delete the Monte Carlo simulation worksheet inside of this spreadsheet, and that won't break anything. The worksheet you will use is called the Beta Scheduler Worksheet. This is what it looks like, the Beta Scheduler Worksheet. And I included in this spreadsheet file for the demo a couple of extra worksheets that will not be in the template that you download. I added them for the purposes of doing this presentation. But the template, when it opens up to the Pert Scheduler worksheet, it's got no data in it. So we'll have to add the data in order to build that probabilistic schedule. In this worksheet, I copied all of the critical path activities for my ERP upgrade project. So I'm going to copy all of those activities, and I will paste them into the Beta Scheduler worksheet. So right-click, and I'll paste those values in. And there's about 20 or 21 critical path activities. It's important to note that you only will schedule the critical path using the Pert Scheduler. Oftentimes, schedules have multiple paths. If you looked at the network diagram of a schedule, there are multiple paths. Pert Scheduler is intended to be used only with the critical path, so be sure you're aware of that. This is the critical path of the ERP upgrade project. Each activity has to be completed before the next activity can start. Those are the activities of my project. Now let's add the durations for each activity. In order to do that, I'll click into my special worksheet that has the most likely duration for each activity. So imagine that I'm working with the project team. The question that I usually pose to subject matter experts is, for the procurement activity, what's the most likely length of time it's going to take to go through the RFP process, vendor evaluations, choosing a vendor, and all of the contract negotiation? How long do you think that will most likely take? By posing that as a most likely question, I know there is uncertainty about the activity. It might happen sooner than the most likely duration. Oftentimes it happens longer than the most likely duration. But most subject matter experts can tell me what they most likely think will happen. And that's what I'm trying to get from them, the most likely duration for these activities. Now that I have the subject matter experts' most likely duration, I'm going to paste them in column H under the most likely column heading. Now all 21 activities, I think I've got 20 or 21 activities, all have the most likely duration. The start date for this project I can enter in cell C1. And notice that in this model and all of the models that I build, the data entry cells are shades of yellow. If you see a yellow shaded cell, you know that is an input cell. Input values go into the yellow cells. And I'll put in for the start date, 3/2/2020 is when the project starts. All right. Now, at this point, the finish date shows 2/28/2020. I know that's not right. It's not right because I have a little bit more work I need to do. I want to focus squarely on the first activity. Let's model the uncertainty of the activity duration of just the first activity, the procurement activity. That will help us understand how we build probabilistic schedules. So I'm going to explore the very first activity, the procurement activity, by clicking into the Pert Beta Charts worksheet. Now, the procurement activity, I know most likely will take 30 days. But since that is uncertain, I'm going to build a 3-point estimate to characterize the uncertainty surrounding the procurement activity. I think that an activity like this can't happen any sooner than 15 days. So in cell B4, I'm going to put 15 days. That's 1/2 of the most likely duration. And the maximum number of days that a procurement activity will take, I think, is twice the length of the most likely sum. So if it most likely takes 30 days, I think it won't take any longer than 60 days. Now I have built a 3-point estimate. 15 days for the minimum. Most likely it's 30 days. The maximum is 60 days. But I need to do one thing more in order to see the uncertainty as a bell-shaped curve, and that is to express my relative judgment about how likely the most likely outcome really is. I will always begin with a medium sense of confidence that the activity will finish around 30 days. I have medium confidence that it will finish around 30 days. We've done procurement activities before in the past. They generally finish around 30 days, sometimes a little sooner, sometimes they take quite a bit longer. But I have a medium sense of confidence that 30 days is the right number of duration days for the procurement activity. I'll select medium confidence, and at that point, I have all the information I need to see the bell-shaped curve. Notice in cell D9, it says with 90% confidence, the lower bound threshold is 20 and the upper bound threshold is 46. If I take those same two values, 20 and 46 days, and I plug it into cells D13 and D14, all of a sudden I will see a tricolor bell-shaped curve that represents the uncertainty of how long the procurement activity will take. With a 90% confidence interval, I know that the area in green is 5%, and the area in red is another 5%, and the area in blue represents the 90% confidence interval. So I'm 90% confident that the procurement activity will take between 20 and 46 days. I do like to share the 90% confidence intervals with subject matter experts just to make sure that I have represented their sense of uncertainty accurately. So I might say to the procurement manager, is it true that about 90% of the time this activity is going to finish somewhere between 20 and 46 days with a most likely duration of 30 days? And if that's not right, I can adjust either my most likely confidence value, which will change the shape of the bell-shaped curve, or I can change the 3-point estimate that I'm using. Let's take a look at how the bell-shaped curve changes when I change my sense of certainty about the most likely outcome. If I am not at all sure how long this procurement activity is going to take, maybe I'm new to the organization, I've never worked with this organization's procurement team, I don't have a medium confidence about 30 days. Maybe I have low confidence. Look what happens when I have low confidence that the procurement activity will take 30 days. The shape of the bell-shaped curve changes its shape. It has really thick tails now because the uncertainty about this activity has been spread outward to the corners of the bell-shaped curve. If I am just completely guessing how long the procurement activity takes, the bell-shaped curve begins to look a lot like the uniform distribution, almost. And if I have really high confidence that the procurement activity will take 30 days because we've done this many times, and I've talked with the procurement manager, and he assures me that it's going to take 30 days, maybe a day longer or 2 days longer, but it definitely is not going to take up to 60 days, I can choose a different value for the most likely confidence. When I choose high confidence, you'll see that the corners have been squished and the curve rises upward. The 90% confidence interval now is between 22 days and 42 days. This is what the bell-shaped curve looks like, where the blue area under the curve is about 90%. There's a little rounding there. It shows 89% because there's probably a little bit of rounding going on. So now, if we have high confidence that the procurement activity will take 30 days, then I might say to the procurement manager, okay, is it true that with 90% confidence this activity is going to finish between 22 and 42 days? And that person can confirm that with 90% confidence, it should finish within that interval. Using the most likely confidence dropdown allows me to change the shape of the bell-shaped curve based upon my subjective judgment about how likely the most likely outcome really is. If I think that the true value will be right around the most likely outcome, then my subjective judgment is high about that most likely outcome. But if I'm not at all certain about the true value being close to the most likely value of 30 days, then I can choose a different dropdown to express how little confidence I have that 30 days is going to be the right number. This is going to be important as we build a probabilistic schedule, because I do want to get a sense of how likely the most likely outcome really is. Now, for this demo, I'm going to stick with medium confidence for all of the activities to simplify this demonstration. Medium confidence is a good place to start until you get better information that increases your subjective judgment that the true value will be right around 30 days or right around the most likely outcome, or your input will tell you that we really don't know exactly when the duration will finish, and so you'll have greater sense of uncertainty about that most likely value. Let's go back to the beta scheduler worksheet now. I'm going to zoom in to make this a little bit easier for you to see. So I have all my activities on the critical path for this project. I have the most likely duration. You'll see that in cells G2 and I2, I'm using some global heuristics to quickly build a 3-point estimate. For each most likely value, I'm taking half that number as the minimum number, as the minimum point estimate, and I'm doubling the most likely outcome to create the maximum point estimate. This is just a real quick way of building a 3-point estimate. You have control over the global heuristics. Just click into the yellow cell and choose a different heuristic value that you think works better. I like to start off with -50% and +100% as my global heuristics when I'm building a schedule. That works well in my context. In your context, you might choose a different global heuristic as you get a better sense of how to build probabilistic schedules. I mentioned that I'm going to use medium confidence for the most likely confidence value. So let me go ahead and add medium confidence to each activity. I have medium confidence that the true value for how long each of these activities takes, I have medium confidence that the true value is going to be around the most likely number, okay? And that creates these little spark lines that show a miniaturized bell-shaped curve for each one of these. They all look the same because I have the same medium confidence about each of these activities. Medium confidence that the true value will be right around the most likely value that I put into my 3-point estimates. Once I have added the most likely confidence drop-down values, you'll see how this probabilistic schedule has emerged. Now all of the start dates and finish dates are populated for me, and you can see how I arrived at the December 8th, 2021 finish date. You'll see that in cell D2, this schedule, even though each activity is planned at 95 percentile, there's only a 1 in 3 chance that this project will finish on time, 2 in 3 chance that it will finish late. So let's look at this procurement activity, the first activity. Most likely the activity will take 30 days, but when we build deterministic schedules, and especially when we don't have buffers on a deterministic schedule, we typically schedule those activities very, very conservatively. And in this case, Each of the activities is scheduled with 95% confidence that the true value will be equal to or less than the 95 percentile duration days. So for the procurement activity, most likely it's going to finish in 30 days, but on this very conservative schedule, we would start off by putting in 46 days. And Parkinson's law tells us that when we do that, probably the procurement activity work will expand to fill up that 46 days, even though we know theoretically it should finish in 30 days or even less than 30 days. Once I put 46 days in the project schedule and people see that, their behavior is modified to fit that 46-day time box. And that's true for the procurement activity and all the other activities. I see that the 95 percentile is very, very conservative, and I don't have any schedule buffers. Let's build a probabilistic schedule by tamping down those probabilities. I'm going to start off by switching it from 95% to something less conservative. Let's start off with an 80% value. So the duration days have all been adjusted. The duration days that you now see have an 80% chance of finishing on time. There's a 20% chance of them finishing late. So I'm taking that very, very safe schedule and I'm creating some uncertainty by saying I don't want a 95% confident activity. Let's be okay with an 80% confident activity. 1 out of every 5 activities is probably going to finish late. I don't know how late, but 1 out of 5 activities now should probably finish late. 4 out of 5 should finish on time. The finish date for this schedule now is September 3rd, 2021. That's really good, except there's only a 1% chance of that happening because of Parkinson's law. I need to add a schedule buffer. How much buffer should I add? Well, in the end of the presentation, I will point you to a model called Soothsayer that will help you calculate a right-side schedule buffer. But here's a heuristic you can use with a probabilistic schedule where all of the activities are planned at 80% reliability. Take the total number of duration days, which in this case is 378. That's the value in cell 104, and I'm going to round this. Cell B104, and multiply that by 6%. And once I do that, I have a schedule contingency of 23 days for a total project duration of 401 days. Now, the finish date for this probabilistic schedule is about 2 months earlier than it was. It's scheduled to finish on October 7th, 2021. But how reliable is the overall schedule? It's difficult for us to tell using the SPERT scheduler, so I ran a Monte Carlo simulation to find that out. When I schedule every activity at 80% confidence, I need to have a total project duration of 401 days to have a 95% chance of finishing this project on time. This is a Monte Carlo simulation model that I ran. It's not part of Statistical Pert. I simply ran this to compare with our SPERT scheduler. All right, so the Monte Carlo simulation says for this project, you need to have a buffer that will in total create 401 days of work. And when I added 6% extra schedule contingency to this project schedule, the total number was 401. It's usually not that precise, but that turned out pretty nice for this demo, that just adding 6% gave me the right number. Now with 401 days, which includes 23 schedule contingency days, for this schedule, I'm 95% confident not to fail on the schedule. That's really good. Now, if I'm more accepting of risk at the activity level and I make it 65%, all of the duration days are compressed even more. I'm expecting now about 1 out of every 3 activities will likely finish late, maybe a little late, maybe a lot late. I need to have a bigger buffer now. And what I'll do to create that bigger buffer, I'll just use another heuristic. Instead of adding 6%, I'll add 12%. With a 12% buffer, The total duration of this project is 382 days. I'm continuing to bring in my finish date. Now the finish date is September 10th, 2021. That's about 3 months earlier than when I began with a deterministic schedule. How confident will I be that 382 total duration days is the right number to have a very high confident schedule? I ran another Monte Carlo simulation, and when you schedule every activity at 65% reliability, in order to have a total project schedule that is 95% reliable, you'll need to have a contingency buffer that creates a schedule duration of a total of 380 days. When I go back to this scheduler, I added 41 days of schedule contingency. When I add 41 to the 341 work days that are part of my 20 activities, the total project duration is 382. Again, with a simple heuristic, I got really close to the total project duration that I would have gotten had I run an entire Monte Carlo simulation. So with every activity at 65%, use a 12% contingency buffer. And lastly, if you're okay with a lot of activities finishing late, I could go to 50% reliable for every activity. That super compresses every activity. Now I'm expecting 1 out of every 2 activities to finish late, maybe a little late, maybe a lot late. If I compress the activities so every activity is scheduled with only 50% reliability, then I need a really big schedule contingency. Instead of 12%, I would make it 18%. That gives me a total schedule contingency of 56 days. The total project is 367 days. The project finish date is now August 19th. That's almost 3.5 months sooner than when we began. So I'm really compressing the schedule, but I still need to know that the schedule has high reliability. When I run a Monte Carlo simulation using activities that are scheduled with 50% reliable durations, the Monte Carlo simulation shows that I need to have a total project that runs for 367 days to have a 95% confident schedule, 367 days. That's a Monte Carlo simulation. If I used my heuristic and added an extra 18%, that was 56 days, that was 367. So again, it's very, very close to what you would get with a Monte Carlo simulation. So the 3 heuristics to keep in mind is if you're scheduling activities with 80% reliable numbers, your schedule is going to suffer some activities that finish late, add a 6% buffer. If you're okay with having more activities finish late and you schedule it at 65% reliable for every activity, add a 12% buffer. And if you're really okay with a very flexible schedule in order to really compress the schedule, but you know that a lot of activities will finish late, so that can cause a lot of disruption to your schedule, you could do that. If you do that, have a very large schedule contingency, and I would suggest as a heuristic, use 18%. This is how you build a probabilistic schedule. List all of your activities, choose how reliable you want the duration of each activity, and then build a schedule contingency for those times when the activities take longer than you expected. Let's wrap up with a quick conversation about some additional resources that are available on my website. I hope you enjoyed that demonstration as much as I enjoyed giving it. Before I end this presentation, I want to point you to Soothsayer, which is my model that is built on the unified scheduling method. We used a simple heuristic in that demo that I just finished to create a schedule buffer. But if you want a little bit more robust way of calculating a right-sized schedule buffer, then try downloading Soothsayer from my website. It's a free download just like Statistical Pert is. You simply go to the free downloads page, and on the right-hand side, you'll see some links, the Soothsayer template and a white paper that explains how to use the unified scheduling method. That's a better way of creating a right-sized scheduler buffer than just using simple heuristics. With that, I conclude my presentation. I'm glad you stuck with me to the very end. If you have any questions about Statistical Pert or Soothsayer, please connect with me on LinkedIn or visit my website or simply send me an email. I look forward to hearing from you, and I hope you enjoy all of the presentations on Risk Awareness Week 2021. Bye.